Okay, so the first thing that I want to do is go over this assignment sheet just to make sure that you understand what it's saying. And then we're going to do some math. I know, it's crazy. Uh, I don't know what else we would do, but okay. So this is today's date, is the 18th. And this column are the things we're going to do in class together. This column is the homework. Does that make sense first? Okay. This packet has every single worksheet that you'll need for the whole chapter. And you can tell when you have a quiz. You have a quiz on the 25th. You have a quiz on the 3rd of September. And then you have a test on the 17th of September, which happens to be my birthday. So I know what I want for my birthday. Lots of A's. I'm hoping. That's what I'm hoping for. Okay. So today we're going to do 4 warm-ups because I'm thinking you guys probably forgot some stuff over the summer. And then we're going to do problems 2 and 3. We anticipated that you guys would not have your Chromebooks yet. So we printed out, if you guys could look in the packet, the warm-ups are first. And then if you flip one more page, there's problems 2 and 3. We're going to do those together. And then the homework, which you might finish in class today, is 6 through 10, which we also printed for you, which is right after problems 2 and 3. We figured that you would not have access to the ebooks yet because you're not picking up your Chromebooks till Wednesday, right? I think it's during your English classes on Wednesday. Nobody knows. I don't either. I'm thinking it's Wednesday, but anyway, so we're prepared. So problems 6 through 10 are printed out right here. Okay, first, does everyone understand what we're doing today? And does everyone understand what the homework is? So let me say it one more time. Today we're going to do warm-ups 1 through 4, problems 2 and 3 in class together. And then the homework is 6 through 10, which I'm going to let you work on in class and you might be able to finish it, which would be great. Okay. Any questions about the assignment sheet? So tomorrow I'll come around with a stamp and I will look at your packet and stamp those 2 things. All good? Okay. All right, let's look at the warm-ups. We're going to do problems 1 through 4. Okay. This page of warm-ups. So how many are there exactly? 26 warm-ups. These will be done in class together. This is not homework. So, you know, when you go to like a sport practice and the first thing you do is warm up, like that's what we're gonna do the first bit of every class period. So every day we'll have a couple of warm-ups. It probably won't be 4. Normally, usually it's just 2. But do not go home and do the warm-up unless you're just like extremely bored. But those are not for you to do at home. So just let them be for school. I don't know. Every year I have kids that go home and immediately finish all the warm-ups. So they're like, I did it. Like, oh, we're going to do those together. But okay. Number 1, first question I have is, does anybody know what these symbols mean? These bars right here. Yes. Like the absolute value. Absolute value. That's perfect. And what's the definition of absolute value? Yes. Number away from 0. Beautiful. Couldn't have said it myself. I think I can go home now. You guys have got it. So distance from 0. Okay, and what you need to know is that when you take the absolute value, these bars become parentheses. So this becomes -6 plus, and -2 is 2 units away from 0. So the bars become parentheses. And what is -6 plus 2? -4. Beautiful. Okay. Number 2, this is also absolute value, but notice that there's 2 things inside. So when you guys learned order of operations, did you learn PEMDAS or GEMDAS? PEM? Okay. They changed it to GEMDAS, and the reason is because it's not just parentheses that come first. G stands for grouping symbol. So it's any kind of grouping symbol comes first. So what that means is you combine those before you take the absolute value. So think of those like parentheses, and they're going to turn to parentheses, but just think of them like parentheses before you do the absolute value. So -3 plus 1 is -2. Absolute value of -2 is 2. Beautiful. Okay, number 3. So parentheses first. So 6 times -1 is -6 squared. And I want to really make sure that we all understand that this is -6 times -6, which is positive 36. Negative times a negative is a positive. So don't write -36 underneath that, write positive 36. So this is 2 minus positive 36. And since it's PEMDAS, parentheses were first, then exponents. And now subtraction. 2 minus 36 is -34. Okay, last one, number 4. So this one we chose in particular because it has minus a negative. What did they tell you to do with minus a negative before in your life? Are those files dusty in the back of your brain? Dusty from the summer? Dusty because it was a long time ago? So I don't know what you were taught before, but what I do is if the minus and negative are right next to each other, I just make them both pluses. Does that look familiar? And you can only do that if they're like literally right next to each other like that. So minus a negative becomes plus, and this becomes 15 over the absolute value of -3. Absolute value of -3 is positive 3, and 15 divided by 3 is 5. Okay. Did anybody bring a calculator today? And if you did, can you please put it on your table so I can see how many people brought calculators? For those of you that don't have calculators with you today, can you guys take a look at the type of calculator that everyone brought? These are pretty much the same ones you use in middle school, correct? Yeah, and these are the calculators that we should be using for this class. So if you do not have one with you, you need to get one. I have 7 in here. There's way more than 7 of you that don't have one. So you're going to need to, I mean, I know it's the first day of school and you probably just didn't bring it, but, gonna have to get that. Okay, perfect. No worries, no worries. Oh. Okay. And hopefully you guys can share those a little bit today on the homework bit. We won't really need it too much for the classwork bit, but for the homework bit we will. Okay, so go ahead and flip to problems 2 and 3, which we printed out for you. At the function factory, a number is put into the top of a function machine, and the machine puts out another number depending on how it is programmed. Did anyone, I don't even know if you'll be willing to raise your hand, but not go to Benicia Middle School and not, okay. So there are going to be, you might not have seen function machines before. Hopefully by the end of today, it'll make sense. Did you evaluate things where you like plug a number in? That's just what this is. So, okay. So if you didn't go to Benicia Middle School, you might have never seen function machines before, but it's not a big deal. Okay. In the illustration at the right, a worker input a 3 and the machine output an 8. This machine is programmed to square the number. So it took the 3, it plugged it in the little X spot, and then it did 3 squared, which is 9 minus 1, which is 8. Does that make sense? Okay. A customer brings a box with a mix of integers. That's kind of a strange thing to have in a box. That's okay. And inputs to a function machine, as inputs to a function machine. She wants you to program the function machine so that the output is always negative. Your manager suggests negative x over 2 minus 10. Did the manager make a good suggestion? Are there any inputs that will not meet the customer's needs? Explain. Okay, I want you guys to take 30 seconds to talk in your group. And the only question you're asking yourselves is, will this always come out negative for every x? Go ahead, talk to each other. It's okay. Will it always come out negative? Does anyone feel confident enough to venture their opinion on whether or not this will always come out negative? It's okay. It's the first day. It's all right. So the answer is no. It will not always come out negative. Let's plug in something like x equals negative 20. X equals negative 20. Let's see what happens when we plug in x equals negative 20. So I would have negative x, and make sure that you have negative and then x, and now you can kind of see what's going to happen. Okay, so what happens when two negatives are right next to each other? Yeah, it becomes positive. Beautiful. So that becomes positive. 20 divided by 2 is 10 minus 10 is 0. Is 0 a negative number? No. Okay. Are there other things that would also make it positive after doing the math? What's another example? Negative 25, negative 26, negative 27. Okay, I put in 20, it came out 0, so what's the next one from that? Negative 21. Okay, so we all agree that everything below negative 20 will give us 0 or positive answers. Yeah. Okay, so all okay, once you've got that written down, go ahead and flip the page over. Number 3, sometimes two machines at the function factory are stacked on top of each other. When a value for x is input into the first machine, an output value comes out. That output then becomes the input for another machine. See the diagram at right, which is not really at right, it's below because we couldn't format it to be at the right, but it's okay. Work together with your team, which is a really big team of 34 people, to determine the outputs from each of the function machines at right if the original input is x equals negative 1. Okay, so put x equals, oh, it's not negative 1, it's positive 1, which is easier. Great. Okay, so put x equals 1 at the top. Okay, then we're going to drop the 1 into the machine where x is. So 3 times 1 plus 1. Do you guys all know that when two things are right next to each other like that, it means multiplication? Okay. Just checking, just checking. 3 times 1 is 3, plus 1 is 4. So that means that 4 is going to be the output of this machine. And then that 4 drops into the second machine. And 4 times 4 is 16. So the final output is 16. Okay. So just to review, you have an initial input. You plug it into the first machine, get an answer, drop your answer into the second machine for X, and then get another answer. Okay. B, would it be possible to get a negative number output at the bottom of the second machine? Explain. Can you get a negative when you have something squared? No. No. Okay. So Hooray, we finished all of the classwork for today. So if you did that along with us, then you are done with the very first stamp, which is right here, 1-2, 1-3. This is done. And then I will stamp that tomorrow when you come in and you show me. Okay, now flip to the homework, which is 1-6 to 110. And I'm going to help you get started with number 6. And then I feel like I'm going to let you work on 7 through 10 in your groups. Just make sure if you don't have a calculator, you can grab one in the pink bin over here. There's 7 of them, or you can share with your table group. It's totally fine. Okay. Sure. All right. Angelica, said that wrong. Angelica is working with function machines. She has the 2 machines shown at right. She wants to put them in order, so the output of the first machine becomes the input of the second. So just like that picture we worked on before where they're kind of like stacked. So she wants to stack these 2. Her initial input is 6. In what order must she put the machines to get a final output of 5? Okay, so let's try it out. What would happen if I put 6 into this one? This would be y equals the square root of 6 minus 5. So I put the 6 in the little tiny x spot. Square root is considered a grouping symbol, so you combine these first. 6 minus 5 is 1. Okay, what does square root mean? Opposite of square. Okay, what I like to think of is what number times itself is 1. What number times it's 1, right? Okay, now if you're using the calculator, there is a square root button. I think it's the 4th one down on the left side, just to let you know. Okay, now what if I put 1 into here? Y equals 1 squared minus 6. Is this 5? Positive 5? No. Okay, so this clearly was the wrong order. So that means that we need to do this one first and then this one. So x squared minus 6, then square root of x minus 5. Okay, let's just make sure that this makes sense. Just doing mental math real quick. Initial input is 6. What's 6 times 6? 36 minus 6, 30. What's 30 minus 5? Square root of 25, 5. Okay. Look at our mental math. We checked it. Okay. Is it possible for her to find an initial input that will get a final output of -5? Indeed. If so, show how she could do that. Oh, goodness, we already did. What do you want to ask? About what? Oh, yeah. It's just arrow. I think I meant like that one first and then that one. I was just, I was trying to be like shorthand. I didn't want to draw the machine. Okay, can you guys take a look at 7 through 10? Okay. I want you guys to play with number 7. Everybody know how to do tile patterns. Number 8, so just draw the next figures. Number 9 is where you might get that calculator out. And then number 10, do the directions make sense for number 10? Just plug in 2 for X and then find Y. Okay, go ahead and work on that, please, and thank you. And you can definitely talk to your group. That's totally fine. By the way, these seats are not permanent. I put you alphabetical at first so I can learn everybody's names, and then we'll move you around. So if you hate your seat, it's temporary. What? I'm a smart lady, but I'm not that good. It takes me like 2 or 3 weeks to learn everybody's names.